Every time you swipe a card, apply for a job, or click a link, billions of automated calculations are silently routing your life. To see the human cost of this architecture, consider John. He walks into his local bank branch to apply for a standard mortgage, expecting a routine approval based on his salary and credit history. This diagram shows John's fate. His financial identity, income, location, browsing, becomes a mathematical input vector, variables x1 through xd, fed into an algorithm. The opaque black box evaluates risk instantly, outputting a deterministic result. Y hat automatically rejects the loan. John immediately demands to know why he was denied. The bank, conversely, needs to know if John actually represents a legitimate financial risk or if the machine made an error. But here is the core engineering failure. Because the system operates entirely as a black box, even the bank's own developers cannot look inside the code to explain the outcome or debug the failure. Deploying highly accurate predictive models without interpretability strips away all human oversight. In the context of big data, these algorithms stop being useful tools and become severe technical and ethical liabilities. There is a persistent assumption among developers and executives that because an algorithm uses math, it is inherently objective. This is completely false. Algorithms are rigid mathematical reflections of highly subjective human decisions. Every line of code relies on choices about what data to include, how to interpret it, and what connections matter. The most impactful human choice is setting the algorithmic threshold. A developer manually dictates exactly where the line for inclusion or rejection is drawn, deciding precisely what percentage of the population gets approved or denied. The data fed into these thresholds is equally vulnerable. Organizations frequently pull information from unverified online sources and third-party data brokers rather than official credit registries, embedding inaccuracies directly into the model. Then there is the threat of compilation. The algorithm constantly stitches together thousands of isolated, seemingly harmless bits of consumer data. By cross-referencing these innocent data points, the system can infer incredibly sensitive information, like medical history or race, generating discriminatory proxies without a programmer ever explicitly instructing it to do so. Mathematical objectivity is a myth. By processing biased inputs through human-defined thresholds, opaque models mathematically consolidate existing prejudices and enforce social stratification, all disguised as pure data science. How did the technology industry reach a point where it builds global infrastructure it cannot comprehend? This graph tracks the trajectory of technological platforms since 1980. The massive scaling of data collection, particularly as artificial intelligence converges with IoT devices, created a staggering technical debt in interpretability. The sheer volume of big data requires entirely new infrastructure layers. We rely on machines because human cognition cannot process or sort information at this magnitude. This diagram maps the full taxonomy of modern artificial intelligence. To make sense of billions of data points, engineers had to build massive, overlapping cognitive frameworks. Looking closely at the left side of the wheel, branches like natural language processing and machine vision intake massive amounts of unstructured data, generating thousands of hidden mathematical connections. All of those unstructured inputs are then funneled to the right, heavily filtered into dense decision-making and deep learning nodes. This creates a paradox. To increase a model's predictive accuracy, engineers add deeper layers to the neural network. But with every layer added, the internal logic and pathways become impossibly entangled. The relentless pursuit of raw statistical accuracy over transparency created a structural trap, rendering the internal logic of the final system entirely opaque. Explainable AI, or XAI, is a set of diagnostic methods designed to translate an algorithm's opaque logic into steps a human can read and audit. Returning to John's rejected loan, XAI allows the bank to finally break open the black box and see exactly what happened. The immediate technical drive is trust. Engineers cannot safely scale models if they don't understand the specific, chaotic edge cases that cause failures. This feature importance chart shows exactly which inputs cause the rejection. By applying an explainability layer, the team sees that variable X4, a single online purchase history, was weighted disproportionately and triggered the denial. This exposes the ethical drive. Explainability provides the only reliable mechanism to catch a model silently amplifying societal biases. Once developers identify the specific variables causing discriminatory outputs, they can excise those connections, protecting vulnerable groups from harm before the system is deployed. XAI transforms a blind predictive engine into a transparent, auditable system. Engineers can iteratively improve the software while simultaneously mitigating massive ethical damage. This shift extends far beyond the engineering bench. In the corporate boardroom, the global regulatory landscape is rapidly forcing transparency. High predictive accuracy is no longer legally sufficient to deploy artificial intelligence in highly regulated sectors, like finance or healthcare. The GDPR framework established the definitive legal standard for algorithmic accountability. Under these regulations, a customer like John has an explicit, protected legal right to demand the logical reasoning behind any automated decision that affects his life. The commercial impact is just as severe. Trust is the absolute limiting factor for the adoption of modern AI services and smart hardware. If companies fail to provide deep transparency on how data is compiled and used, consumers will actively reject these systems to protect their personal privacy. We have reached a critical baseline for deployment. Models must be technically debuggable, ethically safe, and legally compliant. As data structures grow larger and artificial networks grow deeper, explainable AI is the essential prerequisite for maintaining human agency and control over our most powerful computational tools.